Hey, Jude Buckhay. This is my second semester final video for Advanced Math 3, Ms. McElmore's class. First off, I'd like to say that something I really learned about myself in math is that I am very good at keeping up with the concepts that are going on currently in class. I know that I've missed a period of class due to being very sick and being stuck at home, but I was able to conceptually keep up even though I've missed some things, and then I was able to go back and go over those things. So I've learned that I have that particular skill as a student in the classroom. And then I'd like to go on to my favorite topic that we went over in class, and that's the conversion of polar to rectangular and vice versa coordinates. It's really interesting to me because we've always learned to graph a certain way, and that being the rectangular form, and then we've been introduced to this whole completely different way of graphing things on a circular plane. It was just very interesting to go into something completely different like that. And here I have the differences between the two. We have the x and y coordinate pairs, and then the r and theta coordinates. And basically the difference between the two is that x and y is just based on the axis, whereas r has to do with the radius of the circle that you would be graphing on, and theta is the angle at which the point would go on that circle. So here we have the equations that you would use to convert between the two, because you're actually able to convert between the two and get a point on a graph that will have each type of coordinates for that particular point. So for the conversion from rectangular to polar, you have x and y is equal to r times the cosine of theta, and y is equal to r times the sine of theta. You're able to use this algebraically if you're given x or y in the coordinate plane to convert. And given the other way, we have a kind of Pythagorean identity of sorts, where it is r squared equals x squared plus y squared. Another way that you can try and convert to the to r in the polar form. And then you also have the tangent of theta is equal to y over x. Now this can be applied in ways of as normal graphing would be. It's just a completely different way to look at it. It's a different way to look at as far as radians and degrees rather than just whole values. Now to move on to my least favorite topic would be the unit circle. Now the unit circle is actually a pretty easy part of the class this year, but I had my own particular problems. The unit circle is a theoretical basis circle that has a radius of 1 unit, and it's able to be applied to many different things as far as differences in arrival time of planes, as far as their angular velocity, and difference in planned paths. And it's able to be applied on a much larger scale just based off of that radius of 1 circle. And here I have the first quadrant of the unit circle filled out. We have the degrees, radians, and the coordinates of each point or angle. The unit circle is able to be applied on a larger scale, as I mentioned before. But the part that I didn't like about it was I'm not necessarily good at rote memorization as a student. So when we got to the point where we got to the parts that you were just going to have to sit down and memorize, the sine and cosine coordinate pairs of the points on the unit circle, it just became very difficult for me because there wasn't a mnemonic device that I could use to actually sit down and memorize them. But now that I've sat down and looked at that, that also is classified as the unit that I will never forget, because it was memorization. We had to sit down and study the unit circle, and it was easy to get once you actually sat down and looked at it. So thank you for your time, and I'll end the video now.